my dear friends. Myself Tejashwi Kumar and welcome to you in my channel Learn with Tejashwi. And today I am going to give you basic information about the chapter motion. Alright, I am going to give you basic information about motion. Motion is very important, wonderful and interesting chapter. Okay, basically we can say that moving of a body or an object is known as motion. Okay, alright, and as everyone knows that moving object is motion. Okay, an object or a body that moves. Suppose this is my finger. My fingers are moving. When my fingers are moving, means it is moving. My hand is in motion because anything that moves is known as motion. Alright, my fingers are in motion. Now you take this car. What is the work of a car? It takes us from one place to another. And in this process a movement takes place. To this movement we call it motion. Alright, in this process a movement takes place. To this movement we call it motion. Simple. Okay, now look at the definition of motion. So motion is defined as a phenomena that changes its position with time and respect to the immediate surrounding. Okay, when a motion happens, there has to change its position. Means, as I gave you the example of that car, when the car moves, it is changing its position from one place to another. Yes or no? It is changing its position from one place to another, and means it is changing its position. He is changing its position from one position to another. Okay, that's why the car is in motion, because it is changing its position. When the position change, automatically the time will also change. Now you look at the example of this boy. What this boy is doing? This boy is running. When this boy runs, he is changing its position, because at first he was at point A. When he ran, he came to point B. Yes or no? Alright, at first he was at point A, now he came to point B. Means the position changed, because from A to B position is changing. That's why this boy is in motion, and this boy is also moving. Okay, now you take this car. Now, as I gave you already the example of that car, a car moves from one place to another. It is changing its position, and I gave you that when the position changes, automatically the time is also changing. That's why this car is in motion. Alright, till now you are clear. Now you take one more example of a rocket. When a rocket moves, how rocket moves? It moves from down to up. Means it is changing its position from down to up, from floor or from ground to space. That's why this rocket is in motion. Now we'll study about rest. Okay, now we'll start off rest. So a body that do not move is rest. A body that do not move, it stands in one place. Suppose you take this tree do not move, it stands in one place. That's why this tree is in rest, because it does not move. Now definition of rest. Rest is defined as a phenomena that do not move with time. Okay, suppose, or rest is defined as a phenomena that do not move or that do not change its position with time. Rest do not change its position like motion, from point A to point B. Examples: sitting, sleeping, standing. These all people who are doing this work, they are at rest, because they are not moving. Now rest and motion are relative terms. How can you say that? Suppose you are going in a train. When you are going in a train, you look outside and observe. What will you observe? You will observe that there are many trees, lamp posts, etc. Yes or no? And you will see that they are moving. While now see out, observe inside. What you observe inside? That seat, person sitting in a train, they are not moving. They are at rest. That's why these two are in relative terms. Now we'll study about types of motion. There are different types of motion. 8 types of motion: translatory, circulatory, oscillatory, vibratory, periodic, non-periodic, multiple, and random motion. Now we'll start with translatory motion. Okay, the motion of an object in which every point of the object moves through the same distance in the same interval of time is called translatory motion. So suppose a car moves with the same speed. If it covers 2 meters in 1 second with the same speed, automatically it will cover in 2 seconds. It will automatically cover 4 meters. This is known as translatory motion. Same distance, just same interval of time. This sliding of a boy is example of that. Okay, now translatory motion. Two types of translatory motion: rectilinear and curvilinear. Now we'll start about of rectilinear motion. The motion of an object along the straight line is called rectilinear motion. That moves straight. A motion that moves straight, not in this direction, in that direction. It will move fully straight. Okay, it is also called linear motion. Linear means straight. That's why linear motion is given its name. Linear means straight. It is known as straight motion or linear motion. Example, you can take firing of a gun. Firing of a gun. When a person fires a gun, the bullet from there, it moves. It can't go on direction. It has to go straight. That's why this is in rectilinear motion, because it moves straight. Now, a car moving on a straight road. When the road is straight, automatically the car will move straight. That's why this is in rectilinear motion, because the road is straight, even the car will move straight. Okay, now we study about another type of translatory motion, curvilinear motion. So the motion of an object along the curved line is known as curvilinear motion. Rectilinear that moves straight, and curvilinear that move curve. It's in the name itself. Curve is linear motion that move curve. Okay, that move curve. A motion that move curve, not straight. It will move curve. Okay, a basketball being thrown in a basket. See this basketballer named Michael Jordan. This basketballer's name is Michael Jordan. When he's playing basketball, when you played football or basketball and any other games, running games, you can't move straight. You have to move unidirectionally. You have to move curve. Okay, you have to move curve. That's why this basketball bowler who is playing basketball is in curvilinear motion, because he is moving curve and he is dunking curve. Now take an example of athlete running in a curved field or curved line. When this athlete is running in a curved line, see this ground is curved, means they will run curve. That's why this is in a curvilinear motion. I will start about of circulatory motion. So circulatory motion. Okay, circulatory motion. Definition of circulatory motion. Okay, the motion of an object about a fixed point along the circumference of a circle without changing its position is called circulatory motion. See, suppose a rotatory object, a potter's wheel is there, a potter's wheel or a fan is there. It will move circumference of a circle, means it will move circle. It will move circle. It will not move sometime here, sometime here. It will not move sometime here. Suppose you take this fan. When this fan moves, these fans move round. At the circumference of the circle, means it moves at the perimeter of the circle. Means at the end of the circle. It won't go higher. That's why this is in circulatory motion. Hands of a clock. Hands of a clock moves every time, each seconds. It moves each seconds. It round and round and round and round. That's why this is in circulatory motion, because it moves at the circumference of a circle. Now this potter's wheel. When this potter wheels move, even it moves at the perimeter of a circle, because they are round. It is not unshaped. When this is circular, it will move at the perimeter of the circle or at that circumference of a circle. Okay, that this is it. Circulatory motion. Understood? This is in circulatory motion. Now we'll start off next type of motion, oscillatory motion. The motion of an object in which the object moves to and fro or back and forth about in mean position is called oscillatory motion. Now take this simple pendulum. Let me introduce you about simple pendulum. The middle one is called mean position. This side, which is called this side, is called extreme position. Which was this side, it is also called extreme position. And the round shape is called bob. And the displacement is called amplitude. And the point in which it stands is point of suspension, and the support in which it stands is called rigid support. Now this is a simple pendulum. Okay, and the middle one is the real one. Okay, middle one is the real one, and this right left are just imagination. And the middle one, which goes this side, is to, which goes this side is fro, and vice versa. It will go to fro, and also it happens for a long period of time. Okay, it happens for a long period of time. Now vibratory motion. Vibratory motion, the type of motion where every part of the object moves to and fro about a fixed position. Okay, this move to and fro, but this move for a short period of time. Oscillatory motion move for a long period of time. Now take some example. Strings of a guitar. When you play guitar, the strings will move up down up down up down, and for a short period of time means to fro to fro. That's why this is in vibratory motion, and it will move for a short period of time. Now periodic motion. The motion which repeats itself at the same interval or equal interval of time is called periodic motion. This is an example of spring. When you press spring, it will move up down, which repeats itself is periodic motion. Okay, and it will repeat itself up down up. That's why that is in periodic motion. Now swing machine. When you play swing machine, the needle of the swing machine move up down up down. That's why it, and it repeats itself. That's why that is in periodic motion. Now non-periodic motion. When the part of motion does not repeat itself at the same or equal period of time. Okay, the motion which do not repeat itself at a fixed period of time is called non-periodic motion. Periodic motion repeats itself, but non-periodic motion do not repeat itself. Suppose this person is going, when he is running, the hand sometimes will move like this. He can't repeat this. He can't repeat. Okay, now see this car in a busy road. When a car will move straight. Okay, now this road is busy. He can't go back. He's going. Okay, but he can't go back. That's why this is in non-periodic motion. Now we'll study about multiple motion. The type of motion which is a combination of two or more than two type of motion is called multiple motion. It is also called complex motion. Understood? Where in one motion there are two type of motion. See one example of drilling machine. When the drilling machine drill wood, it rotates. That's why this is rotatory motion, and it goes straight. That's why this is in translatory motion. Because at the same interval of time, it is going straight. Okay. Now we'll look into random motion. The motion in which an object changes direction frequently, that is called random motion. It is also called zigzag motion and irregular motion. I think so that you have understood something of it, that this motion move this side, it move indirectionally, fully indirectionally. Sometimes it will move there, sometimes it will move there. That's okay. Now see one example. A flying kite. That you know that flying kite can't move straight. According to the air, sometimes it will move there, means it will move indirectionally. That's why this kite is in random motion. Now another very common example of random motion is smoke. All of you know that smoke moves indirectionally. Sometimes there, sometimes here, sometimes there. That's why this is random motion, because it moves indirectionally. Okay, I think so you have understood. Now I'm going to give you some question. Here we complete a type of motion. Okay, now I'm going to give you some question of it. Do that question and send me in the comment box. Okay, define motion. Write all the types of motion with examples. Define rest. Write 5 example of motion and 8 example of rest. Now we are going to learn very important topic, that is distance and speed. The actual length of a path covered by moving object is called distance. Okay, suppose this is one person. Actually this is location, but believe that this is person and this is another person, and the gap is there. No, that gap, that road, and this is called distance. And that's you need to learn that. The SI unit of distance is meter, and the other commonly used is centimeter and kilometer. Without speed, the distance traveled by an object per unit time is called speed of an object. Okay, an object, how much it covered distance in 1 second or in particular time. Suppose it's a train. This train has to complete some distance, yes or no, with a particular time. That is speed. Now SI unit of speed is meter per second. The other commonly used units of speed is kilometer per second and centimeter per second. The formula for speed and distance. Okay, now distance is equal to speed by time, speed is equal to distance by time, and time is equal to distance by speed. Now see some numerical. See both numerical. This is your distance and speed. Or my dear friends, do this numerical in your copy. Okay, now I'm giving you some question. Differentiate between these three. Okay, and define the following of translatory motion, circulatory motion, oscillatory motion, vibratory motion, multiple motion, and random motion. Do define the following and send in the comment box. Understood? Now I'm giving you some formula. Do learn this formula, because this formula will help you to solve numericals, solve many numericals in higher studies. Now I'm ending my video here. Okay, my dear friends, so if you like this video, please like this, please tap on like button and share this video, because any other person can learn this. Have a blessed week. Goodbye, see you soon.